Hello class, I am going to show you guys how to calculate the means and 90% confidence intervals for the assignment 4 density data for the grazed and ungrazed yellow star thistle. So there are actually many ways to do this. This is, in my opinion, the simplest way. So the first thing I'm going to do is get rid of these top two rows because I want the rows to have headers so that I can easily sort the data. So I'm going to highlight everything, then I'm going to right click. So everything highlighted by clicking this corner, right click. And if you have a Mac, right click is either like a click with two fingers or there are a bunch of ways. You might have to Google it for your model. So sort, and I'm going to go to custom sort here. And I'm going to sort by grazed or ungrazed because as you'll notice over here, the grazed and the ungrazed are not in order, so it'll be difficult to get the means. That's it. Okay. Now I'm going to just bring this information up. So I highlight it. Command X or Control X, depending on if you're a Mac or PC. And then I'll go ahead and delete this row because it's the same. Notice the plot number here is the same. This was before and after, right? So this was ungrazed before they introduced grazing. So this is the after information. So these are the same plots. And that information is available in the PDF with all the slides that you did. So then the next thing, we're going to go ahead and calculate some means. So equals average. We've done this a few times, so I just went down to the bottom and equals average. Let's highlight all those rows and hit enter. And we can drag this over. And just to make sure we're in the same place, I go ahead and click in that square and come up top, and sure enough, we are getting the means. Something I'll go ahead and do is make it clear what we're working with over here. So we have plants on the left column, seed heads on the right column. And this is not necessary, okay? The next thing, so let's go ahead and say we've got the mean here. You can put that in anywhere. And then we want to get the standard deviation, if you remember correctly. That's used to go in the confidence interval formula. So open square equals STDEV. We don't want any of these special ones, just standard dev, same rows. All right, let's drag it on over, get rid of that, make sure we've got the right information highlighted, and we sure do. So that's good. And then we need our alpha values. So this was the simple way to calculate was to use the confidence.t formula, which will be the next one. But anyway, our alpha is always 1 minus our level of confidence. And we are consistently doing 90% confidence intervals. And you'll notice I use the CI abbreviation regularly. So 1 minus 90%, or 1 minus 0.9, is 0.1. So we can just put that in each of the squares here, cells. All right. And finally, we want our confidence interval. Well, let's just go ahead and take this and move it here so we have it labeled. So it's going to equal confidence .t. I noticed on the last assignment, some of you guys were using this or confidence norm. We want to use confidence T, and the reason is to remain consistent, and it is the most commonly used distribution, the T distribution. If you want to learn more about it, you can review the information from Module 1. But in any case, we're going to use confidence T always in this class, confidence T. Okay, let's click on that. And it wants, oops, I already made a mistake. It asks for the alpha. So we have that, we put that here. Then the standard deviation, and we put that here. And then the size, and that's going to be the number of plots. So fortunately, this has already been figured out for us. This is 24. Just click on that. Since I don't want this value to change, I can put some dollar signs in here. That's kind of a special trick. I could just keep re-entering 24 in that value, but let's see what happens there. And now we just want to drag this over. And then we want to just go in here and see how our data's looking. Oh, nice. So it's referring to the correct alpha, it's referring to the correct standard deviation, and it's referring to the correct sample size. It's continuing to go back to the same cell. So this is good. So now we have all the information we need to make our graph. So let's do a little something like this. So seed heads, plants, grazed, ungrazed, and this will be for our means, and this will be for our error, so means. There are a few different ways to do this. This is the way that I have done in previous lectures, as well as the way that it's done in your help video, the how to help making bar graphs with 90% confidence intervals. And I notice this happens a lot where the bar graphs don't have 90% confidence intervals. You guys are just kind of clicking something else, but they need to be 90% confidence intervals. Okay, so we want to transfer our means over there first. And I Control C, I'm going to come over here, and I'm going to paste special because I just want the values to paste, not anything else. Let's go ahead and get our mean values from over here, copy over here, paste special, just the values. Now let's go ahead and do that with our confidence intervals. Control C or Command C, we've got the grazed. Paste special, values, okay, and Command C or Control C over here, paste special, and values. All right, we're ready to make our table. So let's highlight, well, one thing we know, we don't want it to say YST in the, not table, but chart, because as is written in the rubric as well as the guidelines, the abbreviations are not good for charts unless they're defined in the caption, but in general it's not considered good etiquette to have abbreviations in your figures. So, oops. Yellow star thistle plants and yellow star thistle seed heads. Of course, normally common names you don't capitalize, but since these will be headers, we will capitalize them. All right, let's see. Let's highlight these. We probably, with these units here, well, let's see what happens. So we want to insert, let's see what's recommended. Sometimes that's really helpful. Wow, yeah, that's exactly what we want. That's perfect. So we'll insert that. In terms of the caption, let's yeah. I don't know why the meters, we don't want that though. There we go. Because we're going to put that on the y-axis. We don't need it in multiple places. There we go. That's what we want it to look like. Perfect. We simply get rid of that. We can put all that information in the caption. Titles won't dock you off any points, but it definitely isn't necessary, but something we do want is for our axis to be labeled. So I clicked on chart design here, making sure I have my chart highlighted, add chart element, and we want our vertical axis label, and we want this to be density. Whoop. Density in plants per meter squared, and I could go through and try to figure out how to get it to look different, but that's efficient. All right, so now what we want to do is error bars. So notice when I highlight these two blue bars, it shows here that I've highlighted this grazed and ungrazed yellow star thistle plants. So these are the plants, not the seed heads. So I'm going to go to add chart element, error bars, more error bar options. This is all exactly the same as we've done in the past. Specify values. So now I'm going to tell it that it's 90% error. And I already calculated them over here. So you can actually just highlight straight down, and I'm going to do the same for there. So this is showing the direction up and the direction down, which is exactly the same. This 90% confidence interval that we calculated means that's plus or minus that value. So we're just saying that here, plus that value, minus that value, okay? And now let's do it with the plants. So again, we just have to highlight the bars, add chart element, error bars, more error bar options, custom, specify value, and remember it's these two rows now. Okay, and same here. We want to do up and down. So I'm just highlighting, I'm just clicking and holding down as I highlight those two rows. It's very simple. And there we are. So it's not the easiest to read. I might recommend, if you want, doing two different charts. But what's really nice about this is plants are always in blue, seed heads are always in red. We know that we have a 90% confidence interval, so we can conclusively say that these populations are significantly different at the 90% confidence value, and that they're on the ungrazed sites, there were significantly more plants and seed heads than there were in the grazed sites. We can also see that there were, in the ungrazed sites, there were more seed heads than plants. However, in the grazed sites, there were more plants than seed heads. And that overall, seed heads dropped from, 400 plus down to like 5 plus, 15 plus, I guess. Here you can see that value when I go on. The value says 15 there. So we can say, that decreased by like 385 some, plant seed heads per meter squared. And actually that brings me to a point here. This should not be plants per meter squared, but let's go number per meter squared, since we have plants and seed heads, right? Probably won't lose you any points, but anyway. So yeah, there are a lot of things that I can discuss now. Grazing seemed to do a much better job getting rid of seed heads than plants, but significantly both were reduced at the 90% confidence level on average, et cetera, et cetera. All right, have a lovely day. Hope this helps you guys in the future.